Welcome to the Meetup. So in this session, we are going to do a deep dive into real-time analytics with Apache Pinot. So this is a follow-on from a Meetup we did either last week or maybe just before Christmas, actually, where we were sort of introducing Pinot and having a look, like sort of introductory material. So I'm going to pick a few things that I think are interesting, but if you have any particular things that you want me to talk about, and then please feel free to ask about them in the comments, and I'll try and cover that material as well. So just to quickly get us all on the same page, so what is Apache Pinot? So it's an OLAP data store for real-time, low-latency analytics. It stores data in a columnar structure, and then optionally you can add different types of indexes on top of that. It's just distributed. So kind of the data can be split across multiple nodes, and we can have multiple nodes serving queries, storing data, and all that type of thing. And it uses a variation of the Lambda architecture, so we can store some data which is kind of batch or historical data alongside data that's being processed from streaming platforms. And it's all queryable with SQL. And finally, it's open source under the Apache license. This is roughly what it looks like. So we kind of got in the middle. We've got Pinot. So it's got indexes. It's kind of got some sort of aggregation, a little bit of pre-materialization as well. And then sort of on the left, you can see we've got sources. So bringing the data in. And so we can do that from both a real-time streaming platforms, so Kcat, Kafka, Red Panda, as well as tools like Hadoop, Spark. And then you sort of see on the other side, we've got some examples of the types of use cases that people use it for. The architecture of Pinot looks like this. So we kind of got, we're going to look at 4 different components in the session today. So we've got the controller, so that's kind of managing the cluster and managing all the metadata around it. We've got the servers, so there are 2 types of servers. We've got a real-time server and we've got an offline server. We'll be using one server, and it will be acting as both of these, but you can split them up if you want to. And so that's where the data exists, and so the queries kind of eventually come to there to query the data. We've got a minion that can do extra tasks. So if we want to do some sort of like pre-processing task, or adding an extra column, or loading in some data, we can tell the minion to do that for us, and so that we don't put load on the rest of the cluster. And then finally at the top, we've got the broker, and that's where the queries come in and get processed. Okay, so we're going to look first at data ingestion. And so in the last meetup, we looked at this diagram here, which has like sort of the picture of what ingestion looks like. And we're going to start with the streaming approach. So remember that the data comes in from a stream, it gets processed by a server. The server, once it gets a complete segment of data, so where a segment is a subset of the rows with all the columns, then it's going to send that to the DeepStory and as the canonical copy, and it will then get sent out to other servers if we had some replicas as well, and the metadata pointing out where it exists and so on will be in the controller. And so we're going to have a look at an example, let's have a look at an example of how to do this. So I've got a project. I'll share it with you at the end in case you want to try it yourself. But what I've got is I've made like a little script here. I'm using this package manager called T, but you don't have to use that. You could just call Python, but I'm kind of playing around with that. So I've got this event generator, and it will generate us a stream of join and leave events to imaginary live streams. So like imagine this would be one of them, and perhaps some other ones as well. You can pass in the number of users that you want, the number of events that are participating, the delay of when people should join the event, how long the event should be, a minimum length of an event, the maximum length of an event, and how long that loop should run. So by default, it runs every 1 second. So let me just show you what sort of data we get if we run this loop. So if I just come over here. So I just pass it in with some of those parameters, 1,000 users, 100 events. Starting straight away, events are very short, 1 to 3 minutes. And so what you see, it kind of spits out loads of these events. So they're all sort of coming through. Let's pipe let's pipe those into the JQ tool so that we can see what they look like. So let's pick an event. So you can see it's got an event time, we've got an ID of the event, we've got a user, we've got a name of the user, we've got a location where they're coming from, and then we've got a city and a region as well, and then it's got the action. So there's only two in this particular variant of the generator. There's a join and a leave, but I think we could probably add some more things in, like we could allow people to like or dislike an event as well, and we could capture those events too. So what we want to do is we want to get this data into Kafka. So we're going to, i.e., or another streaming platform, but Kafka is the most commonly used one. And so what we're going to do is we're going to create a Kafka topic with 5 partitions. So it's going to be called events. And we can quickly check, did that get created? So we run this get offset shell command. You can see we've got 5 partitions. No, all the offsets are 0, i.e. no events are ingested yet. So we can then come back up. So let's go back up to our streaming command and we'll delete this bit. And so what we want to do now is we want to pipe that data into Kafka. And we can do this using a tool called Kcat. Now, Kcat expects the data to be in the structure of key, some sort of delimiter, and then payload at the end. And so we can use JQ to do this. So you see we've basically piped the data through JQ. We're passing in the -c command. So that means like the compressed or compact. So keep one event per line. The JQ's default is explode it, make it bigger. We then put R, which means, I can't even remember what it means. Basically means it prints it out as JSON rather than as a string. And then we'll give it an argument called sep. So that's the separator. In this case, I just put a smiley face in there. Then inside we build an event ID. So, and then toString just means toString the event the toString of this as it's coming in. And then we join it on the separator. And so you can kind of see what it looks like, right? So we get the event ID on the left, we get the smiley face, and then we get the payload. And then all we need to do then is pipe that into Kcat. So Kcat is a tool for both producing data into Kafka and also querying it. So we'll have a look at the querying bit in a second. So what we're doing here is we're saying, I want to produce some data. This is where my broker lives. So I've got it mapped to localhost port 1992. The topic is called events, and then my key separator is the smiley face. And so if we run that, the data will start ingesting. Let's open up another tab over here. So you can see we've got some events, right? So we've got 200 in each one. We can do it again. It's a little bit more. So you can kind of see like the events are going in. We can also use the Kcat tool to query them. So we can call Kcat with the -c command, and you sort of see the events. So the events are going through at a reasonably quick rate. We could make it quicker. We could change the frequency to be half a second, but I think this is good enough for now. Okay, so now that's generally where like people start when they're going to do some Pinot stuff. So they've got like a stream that is already there, and they want to get that data into Pinot. So that's the next step. So I'm just going to stop this consuming of the messages because we can kind of see it's working. And I'm going to show you a schema for a table that will store that data. So what we've got here, so you can see we've got a schema. So it's going to be called events. So we'll just call it the same as this topic name, but it can be anything you want, right? It doesn't need to match it. And then we're going to specify some dimension fields. So these are generally the fields that we'll be using for doing filtering, perhaps grouping by. And this terminology kind of comes from the sort of data warehousing world. There are also metrics, but like we don't have any metrics in here. So these would be like counts of things. If you had some sort of numeric value, that would be a good one for metric field. And then we've got we need to specify a date time to say, like, so each of the messages is going to have a timestamp. And so you can see we've got an event ID, we've got a user ID, a name, a city, region, action, location. And so by default, Pinot will try to map these column names to something in the source. So i.e. in the Kafka stream. So in these messages, it's going to try to map. So event ID, it will work directly. User ID, it will work directly. Name, yes. city, yes. Region, yes. Action, yes. Location will not. And so if it sees one where it doesn't have a mapping, so such as location, or even TS actually, right? TS is not there also, right? What it will do is it will then go and look for what we call transformation functions. And so those are functions that we define in our table config, which we're going to look at in just a second. And it will then have a look, is there a transformation config that I can apply to create a value for this field? Otherwise, I'm going to leave it as empty. So let's have a look at our table config. So we do table.json. So this is what our table config looks like. So you see, again, the name of the table needs to match the name of the schema. So it needs to be, whatever you use, it needs to be the same. In here, we tell it explicitly which one is our time column, so TS in this case. Then we've got our streaming config. Other thing I should say is we've named it, given a table type of real time. And what that means is if you see table type of real time, it's going to expect to see something under streaming config. And so we're telling it, hey, Kafka, the topic's called events. This is where the broker lives. This is all in Docker. So this is the name of the Docker container. We need to tell it how to consume any messages it finds. Also how to construct a consumer to get those messages, and then how to decode the messages once they come in. And then finally, and we'll go into this in more detail in a minute, we're specifying when should each segment be flushed. And then not to forget, this is how you define a transform config. So these are functions that are used when the data in your stream coming from your streaming platform is just slightly different, or like is like maybe not quite exactly what you need. So for example, date transforms is a common one. So in this case, the date was coming in as in a format that doesn't directly get converted into a timestamp by the Pinot engine, and so we'll just push it the right way using this from date time command. And then the other thing is we've got some geospatial data in here, and so we're going to use this stPoint function on the lat long to create a point, and then finally we're going to call toSpherical geography to create a geography out of it. Now what we can do then is we can go and create that table and that schema. So we'll run it like this. So we're calling the add table command there, passing in our schema file and our table config. And then since we're running this from just where we're basically creating a transient Pinot image to do just this command, we need to also tell it, hey, connect to the Pinot control, the deep dive. Oh, and I should also mention, if you're doing it like this, you need to make sure you connect to the correct network as well, otherwise it won't be able to see Pinot. So that's fine. So we can run that. And you see we get the message saying, hey, the table is created. So that's great. So what we can do is we can go over to our browser now. So we go over to this tab. Just do a refresh. Hopefully you can see it. And we can click on events, and you can see we've got 10,000 events in there. Robert says, what's the difference between a low-level consumer and a high-level consumer? Yeah, sorry, good question. Low-level consumer means that it will process each of the partitions concurrently. So we will get, like in this case, effectively five threads consuming data from Kafka into Pinot. If you would put it as high-level, it will treat everything as one partition. So you can see we've got the data coming in here. We could write a query. So let's paste in a query that does something. So this is counting how many join events have we seen and how many leave. So it's not possible to leave unless you've joined. So you should expect to see join is bigger than leave. So we've got 6,500 joins and 5,500 leaves. Okay. So far, so good. What we're going to do now is just have a look at what's actually going on while we're doing this. So if you come over, click on the Pinot icon and click through to the table. So we can see here we've got a table. So we've got events _ real time. So every you use a real time table, it will always have the suffix _ real time. And so we can see in here we've only got one server, right? I mean, if you had a cluster, you'll see multiple of those. And we've got the schema over here. And then I want to just show you, walk through how these segments work. So as Robert pointed out, we've got the low level consumption. And what that means is you see we're creating 5 segments. And the naming convention for these, or the naming structure rather for these segments, is that it does the name of the table, then the partition ID, so in Kafka it's 0, 1, 2, 3, 4, and then there's an incrementing count for Pinot. So it's sort of, as soon as this one, the first one gets flushed, we go on to, for example, events _0 _1, and then also events _1 or double _ 1. And the thing on the end is the timestamp. So I think this is the timestamp of when that segment was created. So let's click through to the segment. So you can see if we click through to this top one, hopefully it's big enough. Let me know if it's not. The status is consuming. And so what this means, so when data is coming into Pinot, it creates segments in this consuming, or it's sometimes called a mutable state. And so it means that actually if you have any indexes, these indexes are not applied until not applied to the data until it's actually moves out of this consuming state into a consumed state. So at the moment, any data that is coming in, it's flushing like those records down to the disk. But it's also keeping an in-memory version of this for querying purposes. And so you can kind of see, like, you have some metadata about what's going on. So it says how many replicas are there, when did it get created, how many records is it trying to fit in there, what offset did it start at in Kafka, and what's the status in progress. So it's trying to get to a threshold of 100,000 before it flushes. I don't know what we're at the moment. Less than that. It won't tell us how many it's at. It will only tell us once they're in there. Actually, no, that isn't true. I think we might actually be able to find it. So there's a command called, I think it's called segment name, which will tell us. So let's see. A group by. Oh, there we go. Yeah, hopefully that's big enough. But you can see, like, if you use this dollar, maybe I'll paste the query in there in case you want it. So there are some special, what do you call it, variables, I suppose, that you can call, and so you can see how many records are in each segment. So you see they're a long way away from reaching that 100,000. So the next question might be, where is that 100,000 coming from? And so it's all about the flush threshold that we provided. So you've got 3 values that you can provide. You've got rows, time, and segment dot size. Now, if you set rows to 0, then it assumes that it's going to use the if you set, actually, maybe easier to explain it the other way around. If you specify a value for rows, it's going to use that value over the other things. If you specify it to 0, then it's going to try and get it as close as possible to that segment size. But if we get to the time, for example, 1 hour, and it hasn't reached it, it's going to flush it anyway. And so we actually have, hang on, let's see if I can, there's an article about this somewhere that I can share as well, like sort of walking through how this works. So let me just paste that link into the chat in case you want to have a look. So we've got a bit more of an explanation of how exactly it works. And there's effectively what we're trying to do here. So we're using the desired size outcome, but you can choose like which one fits what you want. The other thing that we can do is since 0.11, we can actually forcefully flush a segment. So we can say, hey, I actually want to flush a segment. Is there anything else I should have showed you in here? Yeah, so let me just walk you through the endpoints that we have to do this. So it comes under a feature called pause and resume consumption. And so there are a few endpoints on the REST API. The first one is that you can pause consumption. And so what this does is it sets an is table pause flag, and it forces the commit of any consuming segment. So in this case, remember, we've got 5. So it would force all of those to commit, and then it would stop. It wouldn't do anything for the time being until you tell it to resume, at which point it will unset the flag and trigger a segment validation job to say, hey, we need to get some new consuming segments to start getting data in again. Now, the reason you might want that gap between the pause and the resume is perhaps there's a problem with the stream, or perhaps you made a mistake in one of your transformation functions, like you thought the data was in one structure and it had like, and you wrote like the transformation function slightly wrong, and so you're like, okay, I just want to stop, let me fix this, and then we'll start again. That's what this flow is for. There is another flow where, say you did an update to the schema or the table config and you want it to get picked up right away, or you just want to flush and just get me a new segment, and that's the force commit. And what this does is is another endpoint on the API, and what this one does is it forces the commit of consuming segments. So exactly the same as the pause consumption, but this time it restarts consumption into new ones straight away. And so, as I say, this one would be really good if you change the schema or change the table config and you want to get it changing. Or if you want to demo what happens if you rotate the or force consuming segment to be consumed. So let's have a look. So let's try pause consumption. So if we go in here, so you got this. This is the REST API, and so we can type in here events. So it's going to say, hey, I've set the pause flag for all of these. Go and call the pause status to check. So let's go into our pause status. So if we go events, run that command, and it says there are no more consuming segments. So what we can do now is we can actually resume it. So let's go in here and we'll resume. It says everything is being resumed again, and go back down to pause status. So let's go down there, and you can see it's kind of, hopefully that's big enough now. So you can see everything. We've got some segments consuming again, and notice that the number's gone up, right? It's gone up to 1. So we've got 0, 1. And if we come back, oh, that's a bit big. If we come back onto our table and scroll down here, so well, let's just give it a refresh. So you can see now we've got 10 segments. And 0, 0 will be in the consumed, so it's called online status. And you can see in here, the real-time status now says done, and it processed 5,000 documents. It started at this timestamp, and it ended at this timestamp up here. And then the other thing that we've got extra now is we've got a place where you can go and download it. And what this is what we call the deep store that I mentioned in the diagram before. And so whenever you get a segment going from consuming to consumed, it creates a copy of that and puts it somewhere else. So usually when we're processing stuff, there'll be like a copy of it on the instant storage, but you also have this copy of it somewhere else. So if you added in a new machine and the server was assigned this segment, it will go and pull that down from wherever it is. And so probably most commonly, people are using S3 or Google Cloud or some sort of block storage service like that. But in this example, I've just got it on my host OS. So I'm just going to show you where they are. Let's have a look. Oh yeah, so these are actually some that I did earlier. So you can kind of see these are all my ones that I've got. So where's the one that we've just done now? So we're at 423. Is that the 12th of January? Yeah. So this is the one that we've got just now, and then we've got another one which is events 1. Let's see if we can find that. So there we go. Oh, that one. This one actually. So these are the canonical stores. So I've put it pointing at my what was it deep store folder. So the way I did it is if you look at my Docker file. On the controller, I tell it the data directory is deep store, and so that's where it goes and stores the data. Now, the way that it actually works when that data is being copied across is that we build the segment in memory on our server down on the bottom left-hand side of this picture. The segment there, this is the default config. It then gets uploaded to the controller. The controller puts it in the deep store, and then the deep store would be responsible for sending it out to the server. In this case, maybe it wouldn't necessarily do it because the server already has a copy of it. But if there was another server, it would go, hey, here's the copy, use this copy. If you restart a server that was previously and has got behind, it will also go and bring down this copy. So it's almost like a backup restore functionality as well. Okay, so let's just go now. What we're going to do is we're going to pick one of these segments, and let's have a look at the data in the segment. So you can see down here, in each of these segments, it calls it an index. Effectively, these are the columns inside that segment. And usually you would see that every segment for a table should have the same values in here. And so just to remind ourselves, a segment has all the columns, so event ID, city, name, action, location, region, user ID, and TS, but only a subset of rows. And so there are lots of different segments bringing in all that data. And then when you query, the query engine goes and combines all the data from sometimes from all the segments. Sometimes it will work out, oh, actually, because of a filter that you put into your query, I don't need to go and look at that segment because I can kind of see from the metadata that it doesn't have any data that's interesting to me. Now, what you can see here on every single one of these columns, you can see they've got dictionary true and forward index true. Now, I would say the name forward index is slightly misleading. It's not really an index. It's effectively the basic storage technique used for data in every column. Now, until recently, you always had to have this, but since I think it's maybe the most recent version, it is possible to disable the forward index, but you need to have another actual index enabled because this is effectively the storage of the data. Like this is what we assume exists, unless you set this other config, and then it will assume one of the other indexes exists. And for this forward index, or this sort of default storage, there are three types. So there's dictionary encoded, there's sorted, or there's raw value. And these techniques are quite similar to what you'll see in other column stores, and even reasonably similar to what you'll see in sort of big data storage formats like Parquet. Probably I know Parquet a little bit better than Orc, maybe even Avro as well. Or maybe Avro is actually more row based, but yeah, like they're taking data within a column and then sometimes using some sort of compression techniques. So the way the dictionary encoded forward index works, imagine we've got some values coming in for regions. We've got California, Vienna, England, Tokyo, and Singapore, and it's going to assign a dictionary ID to each of those. And then the way they would be stored, it's not going to be exactly like this, right? There's going to be some more compression than just literally storing the number, but it then effectively, like conceptually, stores it as 0, 1, 0, 2, 0, 0. Now, that works quite well for this one, right? Because there's some duplication of values for region. For the UIDs, for a value such as a UID, it's not so good because you have 3185 is 0, 7F is 1, 5C is 2, BB is 3, 39 is 4. And so you just end up storing the numbers. And so this one, like this index, it works best if there are some duplicates like in your data. Otherwise, you're just going to end up with an entry in the dictionary per value in the column. So you effectively create a dictionary mapping every single thing, and then you store it with every single thing. So you're not really gaining anything by doing that. So you want to make sure. Robert says, can't the server also push this segment to the DeepStory directly? Yeah, there is. Yeah, hang on, I'll just come back to that. So there are like some config that you can set where you can control the different ways that the data gets pushed. So you can kind of see it on this page here. But by default, it goes through there. But yeah, you can, if you look at the decoupling controller from the data path, there is a way that you can kind of cut out the server, the controller acting as the middle man, so to speak. Okay, so I didn't spot your question. I'm just going to come back to here again. Okay, so in the case where you've got these like really unique values, so UID being one of them, you're sometimes better using a raw value forward index instead. And so that basically just skips the dictionary step and just goes, okay, I'm just going to store the raw values. Now, obviously, if you have some duplicates, maybe not so good because you're storing redundant storage. And this actually works best if we have very few or no duplicates in a column. It gets rid of that dictionary lookup, which can be slow, right? Like we don't necessarily want to have a dictionary lookup if we don't need one. And it means that for some queries, if we want to just sequentially scan something, we can actually just go, hey, get me all that data, and I don't have to go, okay, go and get that value. Okay, now look it up in the dictionary and tell me what the actual value is. We can skip that whole thing. We can just go and read all the data. Okay, so just a quick table to compare the two against each other. So dictionary, the compression is good when low to medium cardinality. It lets you do, for example, invert index, as far as I know. It only works with dictionaries, but it adds a level of dereferencing, so it can increase the disk seeks. And then if we've got strings, it adds padding to try and make all the values equal length. So if you're using strings, it may actually be better to just go for the raw value. From the raw values point of view, it eliminates padding overhead. You can't use some of the inverted indexes. Like there are only some indexes that you can use. But if you're wanting to just scan like a column, it's pretty good. And we're sort of reducing or chunking decompression overhead with docs selected don't have spatial locality. Okay, so now let's have a look at another one. So another one, a fourth one, a third one, is the sorted forward index. And so this one will actually be applied automatically by Pinot if it can. And so what it means is imagine we have some data like this. We've got document ID and row ID are kind of similar. So we've got 0 is California, down to 10 is California, 11 is England, 12 is England. And so instead of storing each thing individually, it's going to put them in order, and it's going to say, okay, I'm going to conceptually have this table that says region California, starting from 0, going to 10. And so I don't need to go and look those up. I just know, okay, these 10 are California, these 7 are England, and these 8 are Tokyo. And as I say, Pinot will try to do this for as many columns as possible when the segment is committed on real-time tables. But we can also tell it explicitly, and it does it once it's moving from that consuming to the consume state. That's when it tries to sort it. Although in our case, it hasn't managed to sort anything. And so none of the data was sorted. But if we would tell it, hey, I want you to sort on a particular column, then it will actually sort. We'll go and sort it on that. If you're using offline, or batch data ingestion, you need to sort it yourself. Like Pinot won't handle that bit for you. Okay, let's see, what else have we got? So what I want to show you now is I was going to show you the timestamp index. So what a timestamp index is what it does is you can effectively, on a timestamp column, one of the common queries that people sometimes do is they say, I want to query by like a rounding of the date. So they say, I want to, there we go. I want to find rounded to the second, for example, count me all the things rounded to each second, so basically eliminate the milliseconds, show me all the values that happened after the 11th. And then we get the count. And so this is actually having to go and run this function every time, and then use the result down here. So it's not necessarily like fast, right? Like at the moment, it's not too bad because we didn't have too much data, but we can probably get it a bit faster than this if we didn't have to run this date trunk function all the time. So let me just show you we're going to update our table config to add a timestamp index. So the timestamp index is effectively this field config here. So we need to add this just above our ingestion config. And what it does is it says for the field timestamp, it's a dictionary. I want you to add a timestamp index on the minute and second granularities, i.e. the minute and second passed in here. So if we come over to our table, let's go to our table and we'll edit the table and where does it need to go? Just above the ingestion config. If we paste that in there, oops, no, I copied the wrong thing. Let's copy that. There we go. If we save that, and then what you need to do when you do a table config change, you need to tell it to reload the segment so that it's going to pick up the change that you've done. And now if we scroll down, if you look for timestamp, you can see it's added some extra fields in. And so what it does is it adds those fields in, and you can see over here they've got a range index applied. So if I just walk you through what we've done. So what it's done in the background is you have that timestamp index. It creates you 2 extra columns, so $TS $minute and $TS $second, and they're rounded appropriately, right? So the minute one is rounded to the minute, the second one is rounded to the second. And effectively in the background, it's going and adding these derived columns using the date trunk function. And then also adding a range and I've got up there a range index to each one, which is kind of neat. And so you can see, so what it then does is when you see this query, So if we run it again, you can see we've kind of roughly halved the query, and what it's doing is it's replacing it with this. You see, this is the same. This is the same. So when the query planner sees that date chunk, it replaces it with this new field that we created. Okay, so that's timestamp indexes. Maybe I'll show you. Hang on, let's have a look. Let me just remind myself the syntax of the of the sorted index as well. So we can maybe put one of those on our table. So let's just quickly go there. Sorted for, there it is, sorted forward index. If that goes under the table index config. Let's put one of those in as well. So we go back, edit. Let's enter that. All right, table index config. Let's put that on TS. Reload. Let's see if it's going to pick that up. Give it a few seconds. So where's TS? It's not. Maybe not. Maybe you can't do it how I tried. But the nice thing about having it sorted would be that it will then put, like if you're doing a query on that column and it knows that it's sorted, it can kind of do that sort of filtering much more quickly than if it has to go and scan through it. I'm not sure why that's not getting picked up. I must have made a mistake somewhere. Never mind. We'll skip on to the next thing. So the other thing I wanted to show you is how you can load offline data into the same table. And so we're going to use the same schema but a different table config. So this is what our table config looks like for offline. It's the same name, but offline, and again, the schema name is the same. Everything else the same, right? So let's just add that table. One thing that's been changed recently is that when you want to add in a second table, you need to treat it as if you're updating a table, like the whole table config. So you need to pass in this -update command. And so what it does now is, if we go over to our table config over here, you see we've now got an offline table and an online table. Now we don't have any segments in there because you need to explicitly load data in. And usually we would do that using a job config. So for example, let me just show you what one looks like. So Pinot. So it looks something like this, right? You define like, hey, I've got my runner. I want you to get data from here. I want you to write it to the DeepStory. I want you to load the controller and so on. A recent addition to Pinot is that you can do this through SQL, which is quite cool. So we can use this insert into syntax. We say, hey, I want to create a task. My data is on the local file system. This is the glob that you should use, and I want you to load from the batch data folder. So if we run that, it'll sort of go off and run it in the background. And you see our number of documents went up to 157,000. And if we then call $segment name with our count star query, group, sorry, can't type, group by $. You see here, we've got this offline one. So you see there's 99,000 coming from the offline. Now, when it's querying, the way that it works out where it's going to like get the data from is it effectively. Oh, sorry. Hang on. Before I explain that, let me just explain to you what's happening when we run that insert into. So we run that query, and what it does is it sends the query out, and if it goes, it can either go to the controller or the broker. Now because we run it in the UI, it sent it to the controller. And what happens then is that they both have an API, and then they send it on to the minion, and the minion then goes and processes it. So the minion in this case needs to have access to wherever the data is coming from. Usually people are using this with S3, but in this case, as I mentioned, I've got it mounted onto the batch data folder. So this is just another folder that goes, if you have a look, batch data folder. So you can see I've got this events folder in here. Let me just batch data. Batch data. Oh, what have I done? Batch data events. Let's just get a few of the events from there. Ed -N5. And then. This is what we've got in there. So these are some events that I created, when was it? Like 3 days ago. I just put them in the file. And what then happens is that when it's trying to work out, okay, well, when you do a query, should I look at the offline or should I look at the real time? And what it does is it works out the what we call the time boundary, and then when if something falls before the time boundary, it's going to look in the offline, and if it falls in after the time boundary, it's going to go to the real time. And the time boundary is worked out by looking what's the most recent entry in the offline table, and then it will subtract by default. It will go back 1 day, and so it will assume everything a day forward, I'm going to read it from real time, and everything back a day, I'm going to read it from offline. But I've actually configured it to do it for just an hour, and so what it's going to do is it's going to get anything back by an hour from offline. And so you can actually find out the boundary by asking the broker. So we can call the broker and say, hey, what's the time boundary for the events thing? So we call our boundary, and hang on, I don't have. But it's going to say, okay, the time boundary of where, so it's going to read everything before 5:41 on the 9th of January, that's going to be offline. Everything more recent than that is going to be real time. You can read more about how that works in this article. Okay, next thing, we're at 45, so we've got about 15 minutes left. So I just want to show you some other features. So next thing I want to show you is something called upserts. So the idea with upserts, so when you're ingesting data usually, and this is a real-time feature, when you're ingesting a feature normally, what happens is the data comes from the streaming platform, in this case Kafka, it goes straight into Pinot. When you have upserts, what happens is the data goes into Pinot, that's still cool, but there's then this extra table in memory, effectively. Like, you can imagine it's a table and it's going from some sort of primary key, pointing at the latest document ID that it's gonna look up. And so and then when you do a query and it hits that particular document ID, it's gonna go, okay, which thing does that refer to? So rather than just going and looking it up, it's gonna actually check, okay, which one should I be referring? And the idea here is you can have multiple of the entries, maybe updating, like perhaps updating a status. Like, imagine you did an order in a restaurant and the status was being updated, but I want to just see the latest status, but also have the other statuses if I need them later. So that's the intention with the upserts. And so you have to slightly tweak the way that you define your schema. So in this, the addition here is we need to specify what's the primary key. You can also, so you specify a primary key, and then in your table config, you need to turn it on. So you need to specify that upsert mode should be on. We're putting it as full. There is also a partial one where you can kind of handle partially updating a row. And then you can also specify a hash function. So if you had a really big value in a field, you could choose to hash it, and it will then use the hash as the primary key instead. You also need to make sure you have this configured. So reading pointing at the same replica group. And for the data coming from the stream, it needs to be that the things with the same key, the same primary key that you're using, need to be on the same partition coming from Kafka. Otherwise, it won't work. Now we can then run that, and it will create us an upserts table. So if we come over to Pinot, which one has the, yeah, there we go. So you see we've got our upserts table, and you see they all got leaves. So let's pick a person and an event. So if we pick, let's choose Johnson Creek. So if we put that event ID in, and that was the user ID. Here we go. So this is what it does. So for a particular event and user ID, it only captures the latest entry, but you can actually tell it, turn the upserts off. You can say skip upsert equals true, and then it will get you the history. So you can see the join was on the, it only stayed for 5 seconds. The join was at 16:10:28 and the leave was at 16:10:33. So that's the idea with the upserts, and you can kind of do cool stuff. Like we could say, hey, and what it allows us to do is we could say, hey, show me how many people are currently in like which event has the most people currently there. And then if you bring the upsert, is that right? Yeah, if you put the upserts on, we can see how many people attended ever rather than how many people are just there now, right? So you can kind of get two different answer two different types of questions. Okay, one more. So another interesting feature, which is kind of similar to upserts, but also subtly different, is dedupe. So this is added in 0.11. And the idea here is that, again, we have this table intersecting things, but this time we're going to throw it away. Like if we get a duplicate value, we just throw it out. We don't keep it anywhere and then handle this table looking it up. We're just going to throw it away. So let's have a look at how that works. So again, we're going to have a slightly different schema with, in this case, primary key. I've reduced the number of columns just to simplify it. So I'm saying I only want to capture one event per user. And then let's have a look at the table config as well. The table config. Again, you need to say, I need to read it to the same place, and then the dedupe config needs to be enabled. And so we can create that table too. So there's the dedupe. And so what we can do with the dedupe is refresh. So say we want to count each user. All right. Each user ID. I'm trying to think if I've done this right. We see the user coming in 5 times. Whereas if we do it here, they come in like 95 times, right? So we had set the dedupe was on the, what field was it on? How do we get the schema? There's a schema. So we said it's going to dedupe on the user ID. So the user ID field is going to be unique. And so it's going to stop those duplicates from coming in. Yes, Robert. Yeah, exactly. Yeah. So when you use upsert and also dedupe, you need to make sure your Kafka topic is properly partitioned. So yeah, that's more or less what I wanted to show you. If you want to grab the code and try it out yourself, it sits here. So GitHub Needham Pinot deep dive. Yeah, paste that link in as well. Let's put it over here. Otherwise, yeah, if you want to learn some more stuff, have a look at the StarTree YouTube channel, dev.startree.ai, and come and join the Slack and ask us any questions. Equally, ask me questions now if there's any questions on stuff that we covered that you'd like me to talk about. Otherwise, I'm going to assume that everything is good. Cool. All right. Well, thank you for coming. And we're doing another one next week on Tuesday, where we're going to have a look at the modern streaming stack and kind of building an app with Pinot and Red Panda, the streaming platform. So maybe we'll see you on that one as well. Thanks, everyone. Bye-bye.